In this lesson, we're going to be looking at another form of transformations. So far we've looked at, for our transformations, dilations, translations, and reflections. Now we're going to be looking at rotations, which is rotating, spinning something around a central axis. We're going to focus on identifying a rotation and drawing the image of a shape that is rotated, and creating and analyzing designs made with rotations. The outcomes we're going to cover are create, analyze, and describe designs using translations, rotations, and reflections in all four quadrants of a coordinate grid. So what is a rotation? Like I said, it's spinning an object around a central point. It's a transformation that moves an object around a fixed point that is called the center of rotation. And the center of rotation is the point about which an object is rotated. So in the diagram here, we have a center of rotation. We're seeing that our object is being spun. The light green or light blue object right here, this is our original object. And we have our center of rotation right here at the origin of our coordinate grid. And that leads to a rotation giving us this blue triangle, this dark blue triangle. So my object is spun around. We can see mosaics often have repeating patterns of tiles. And in this particular mosaic, the orange hexagon in the mosaic is rotated to create a tiling pattern. So I've got my, I'll pick one here. I've got my hexagon here. If I want to get my hexagon from here to here, what I'm going to have to do is rotate my hexagon around a central point right here. So if my hexagon gets rotated around, all of the parts of my hexagon get spun around. Okay, and that'll give me this hexagon right here. If I want to rotate in the other direction, maybe I'll go a full 180 degrees. I'm going to end up getting to this hexagon right here. Okay, they're created by rotating around this central point right here. And there's a couple of ways we can make rotations. The first and the best way, I guess, in terms of being able to do all the different types of rotations you might see, is using a protractor and a compass, or tracing paper if you don't have a compass handy. So the object on the left is our protractor, of course, which gives us our angle measures, and our compass is an object that helps us make arcs or make full circles. So for example, we're going to look at rotating this this rectangle 90 degrees clockwise, 90 degrees counterclockwise, and 180 degrees. Doesn't matter if we're going clockwise or counterclockwise. When we rotate 180 degrees, we're going to end up in the exact same spot. So we're going to look at rotating the rectangle using our origin as the center of rotation. So it's in pink here in this diagram. You can see that the origin center of rotation is right here. So I'm going to take this line essentially and I'm going to rotate it 90 degrees clockwise first. Later I'm going to do it 90 degrees counterclockwise. And lastly I'm going to rotate 180 degrees. So we're going to use two different methods. The first is the method that we've already discussed, which is using a protractor and a compass, or tracing paper. Okay, so that's the first method. What we're going to do is we're going to use our center of rotation to draw an arc from each point in the object. So with this, you're going to set your compass. I'll just go back real quick. We're going to set our compass on the origin right here, and our compass is going to kind of be a triangular shape like this, and our other mark is going to be, say, on this point right here. And we're going to be wanting to rotate clockwise first. So we're going to take that point and we're going to rotate it down like this. And we're going to open up our compass and we're going to rotate from this point, which is going to bring us something like that, and so on and so forth. And we'll see real quick. Now when we rotate all of our points, we can create almost a complete circle. Now if you don't have a compass, what you can do is take a piece of tracing paper and place it over top of this this object right here, and you're going to put a point on the center of your tracing paper, and you're going to hold it in place, and on the tracing paper you're also going to draw the object as you see it, object A, B, C, D. So we're going to draw this in. Okay. Next, what you're going to do is while holding the center of your tracing paper in place on the origin, we're going to rotate our object using our protractor the correct amount of degrees. So we're going to rotate until we get to, in this case, 90 degrees. So we're rotating our object. Okay, so we place the center of the protractor on the origin. So the center of our protractor, which is along the bottom, looks kind of like this often. Here's the center, so we're going to place that on our origin right here. And we're going to draw a line from the origin to point A. And we're going to find a 90-degree angle using our protractor. My 90-degree angle is going to look something like this. So this should be 90 degrees. Okay, this is point A right here, so we're going to relabel this point down here A prime. So here we go. This is my 90-degree angle, and this is where point A prime is now. We started with point A. We rotate 90 degrees along our arc. Here's our arc right here. And we're going to end up at point A prime. Now that's for A and A prime. We're going to do the same thing for B and B prime. We're going to create B prime. We're going to do it for C and C prime. We're going to do it for D and D prime. And when we do, this is what we're going to see. If you drew a line connecting our center of rotation, which is right here, to B, and you connected one to B prime, my line's a little off there, but you're going to see that this is also a 90-degree angle. And if you do it from C to C prime, you're also going to see a 90-degree angle created. Okay. Secondly, it asks us to rotate the original object 90 degrees counterclockwise. So we're going to follow the exact same steps. We're going to put our protractor on our origin, and we're going to create an arc. And then we're going to take our, we're going to use our compass and put it on the origin and then draw arcs from each point. And then we're going to use our protractor to measure the angle 90 degrees. And this time 90 degrees counterclockwise, so going in the other direction, so heading in this direction. So we started at the point A right here, and we ended up at the point A prime right here. And we're going to do that for B, C, and D as well, and so we get, this is our image right here. Lastly, we're going to do it 180 degrees. So again, my point of origin is right here. I'm going to place my compass, the point of my compass, on the origin. I'm going to extend my compass to point A, which is right here. And I'm going to draw an arc from point A. Then when I get to 180 degrees, using a protractor, I'll measure that. I drop my point A right here. My arc will probably continue on like that. So my point A is right here, 180 degrees from the original A. Now I'm at A prime. I'm going to do the same thing with points B, C, and D. I'm going to rotate all of them 180 degrees. And I end up with this image right here. And again, it says here it doesn't matter which direction. I could have rotated clockwise like I did, or I could have rotated counterclockwise, which is in this direction. If I rotate it counterclockwise, I'm still going to get to that exact same point A prime, because it doesn't really matter which direction you travel when you're traveling 180 degrees. You're halfway around a full circle. Okay, so that's the first method, using a protractor and a compass. What we're going to do now is develop the second method by investigating what exactly we have created in our new images. So we're going to compare the points A, B, C, and D, which is our original object, with our image points, which are A prime, B prime, C prime, and D prime, first from the clockwise rotation. So the point A is at 2, 2. The point A prime is at the point 2, negative 2. If I look at B, B in my original object is at the point 5, 2. And B prime in my image is at 2, negative 5, and so on and so forth. Now I've got this table finished in much neater computer-generated table here. All right, so what I see is A goes from 2, 2 to 2, negative 2. B goes from 5, 2 to B prime 2, negative 5. C is 5, 4 in the initial in the original object, and it's 4, negative 5 in the image. D is 2, 4 in the original object, and it's 4, negative 2 in the image. So here's the table written again, just so that we can try to come up with some properties or some relationships we might see here. So do you see any pattern in how the numbers are arranged from A, B, C, and D to A prime, B prime, C prime, and D prime? You might notice that the original points are in the form x, y. They all switch. It's not as obvious in A necessarily, because the A and B are both the same, or sorry, X and Y are both the same. But in B, point B, this was my X here, and this is my Y. What was Y in B is now X in B prime. So they switched. What was X in B is now Y in B prime. But also, I had positive 5 in B, and it's negative 5 in B prime. So the new Y is also the negative of the old X. I had a positive 5 in B, so that gives me a negative 5 in B prime. Same happens in C. I've got 5 and 4 in C, and in C prime, it goes from 4 to negative 5. Or sorry, from 4 to negative 5. So for any clockwise rotation, we're going to see that pattern. Whatever the point xy is in the original object, the new point is always going to be y, negative x when I rotate 90 degrees clockwise through the origin. For 90 degrees counterclockwise rotations, I'm going to do the same thing. I'm going to compare A, B, C, and D with A prime, B prime, C prime, D prime, which is my new rotated image. Well, here's my table for this one. A is 2, 2, B is 5, 2, C is 5, 4, and D is 2, 4, just like in the last table. Now what happens is I've got A prime is negative 2, 2. In B, it's negative 2, 5. In C, I've got negative 4, 5. And in D, I've got negative 4, 2. So once again, I have my x and my y's in my new points exchanging places. In the last example, when I rotated clockwise, the y's now became negatives of what the old x was. In this one, the x becomes the negative of what the old y was. So what we find is that if we have a point xy on our on our original object, the new point is going to be negative y comma x in relation to our old point. It still is, every point is still technically listed as xy. It's just that the value of y in the original point now is the same, but with a negative, as the value of the x in our new point. Lastly, we're going to look at 180-degree rotation. We're going to compare A, B, C, D with A prime, B prime, C prime, and D prime. We can see our rotation to the right, and when we create our table, our A, B, C, and D values are going to be exactly the same as they have been in the past. But now I have A prime is equal to -2, -2. B prime is -5, -2. C prime is -5, -4. And D prime is -2, -4. So what's happened here? My x and my y's don't change places this time. What was x in the first example, in the original object, is going to be x in the image as well. But everything is going to be negative of what it used to be. We had two, both the positive points in A, and in A prime we have -2, -2. So in general, what we see is that if the old point is xy, the new point is going to be -x, -y. So this is just a table that summarizes that information. If you're making a 90-degree clockwise rotation from the origin, and I've specified the origin many times here, it's very important that we only use this if we're rotating from the origin. If the original point is xy for a clockwise 90-degree rotation, the image point, the new point we're going to create, is going to be -yx. If we're going 90 degrees counterclockwise, so clockwise, of course, is going in, say, this direction. If we're going 90 degrees counterclockwise, that means we're going to be traveling backwards on a clock. So if we're going 90 degrees counterclockwise, if we started with the point xy, we're going to get the new point, the values of my x and y are going to be the same as from the old point, y and -x. And lastly, if we got a 180-degree rotation, and it doesn't matter if you're rotating clockwise or if you're rotating counterclockwise, you're going to end up at the same point in either case when you're rotating 180 degrees. So if my original point is xy, my image point is going to be the negative of what I had originally. So it's going to be -x and -y. The x and the y's do not change places this time, but they just become negatives of whatever we had before. So using this rotation rule is the second method that I was referring to. I said there's going to be two methods for making rotations. Well, this is the second method. And this works great when you have your points passing through the origin. It doesn't work quite so well if you don't have your points passing through the origin. So in this example, we have actually had our center of rotation to be the origin. So using the rotation rule and creating tables, we're kind of working back in the other direction now, using our point we get this table, which is a table you're probably familiar with because we've seen it already. But what we see is that this was x, this was y right here. What we've created is our new point is still xy, but in terms of point A, it's going to be the same as y and negative x. This is x and y, so now we've got y and negative x, and so forth. That's an x, and make sure I see that's clearly an x. Okay, so that's for 90 degrees clockwise. The rule again is we start with xy. Our new point is going to be y negative x. So if we're doing 90 degrees counterclockwise, I'll have to write this out every time. I'll leave it again till the end. So we have 90 degrees counterclockwise. My x and my y's exchange places, so this is x and y originally. Now I'm going to end up with negative y and x. Here we have x, y originally. I'm going to end up with the negative of y and x. And we see the pattern repeating itself for C and D as well. For 180 degrees, again, we don't specify direction because it doesn't matter. You're going to end up at the exact same point, whether you go clockwise or counterclockwise. I started with xy, and I ended up with negative x and negative y. I started with xy, 5 and 2. I ended up with the negative of 5, so negative x, and the negative of 2, so a negative y. So the pattern for 180 degrees is that it's going to be negative x, negative y when you do a 180 degree rotation. And so using these tables, we can create this chart right here. Here's my original object. And this is the first rotation, 90 degrees clockwise. The second, 90 degrees counterclockwise. And the third, which doesn't matter which direction you travel, you're going to end up at the exact same place. And that's 180 degree rotation. So I'll quickly write out the rule again. We start off with x, y. We're going to end up with, for this one, y comma negative x. For 90 degrees counterclockwise, and we start with the point xy, we're going to end up at the point negative y comma x. And if we're starting for 180 degrees, we're starting at the point xy. We're going to end up at the point negative x. Negative y. Try to make that look as y-ish as possible. There we go. So it's negative x, negative y for a 180 degree rotation. So we're going to rotate the parallelogram here 90 degrees clockwise and 90 degrees counterclockwise using 1, 1 as a center of rotation. Well, 1, 1 is not the origin, so my center of rotation has moved. As a result of that, the rotation rule will not work, not how we like it to. The rotation rule only works when the origin is 0, 0. Or sorry, when the origin is the center of rotation, I should say, sorry. The origin is always 0, 0. Okay, so in this case, we must use our compass or tracing paper if you don't have access to a compass, and a protractor to perform our transformations, our rotations in this case. So using point 1, 1 as a center of rotation, we're going to draw an arc from each point, and we're going to measure the center of the protractor on the point 1, 1. Then we're going to measure 90 degrees clockwise from these points and draw the image. And this is what we see. So every point could be point A, could be point B, could be point C, or it could be point D. Every single one of those points are rotated 90 degrees from where they started in a clockwise direction. Now I just realized I forgot to put in the counterclockwise rotation, but we can attempt at least a couple of those points. If I'm at the point A right here, I do 90 degrees counterclockwise, putting my compass there. It's going to be rough, but it's going to look something like that. And my protractor, I'm going to be at the point right here. For A, I'll call this A double prime, since I was on the same graph. Okay, so that's a 90-degree counterclockwise rotation. And you can see this is the point right here. A is at the point 2, 2. So A is the point 2, 2, but, sorry, A double prime is at the point 0, 2. So we see that our rotation rule wouldn't work because A double prime is not just the exchange of our X and our Y from A. And again, this is why we have to use a compass and a protractor, or tracing paper and a protractor. So to summarize rotations, rotations move an object around a center of rotation, like an axle in a wheel, right? If you have an object, a rock, say, in the wheel, stuck in one of the treads of the wheel, then you can watch the rock spin around on your tire, on your wheel, and the center of rotation will be the axle of that wheel. Okay, so the center of rotation is a fixed point that an object rotates around, much like the axle of a wheel. When the center of rotation is the origin, so that is very key here, when it is the origin, and only when it is the origin, there is a rotation rule that we can use to find the image. And we've written this before, but I'll summarize again. 90 degrees clockwise, the original point xy becomes the point negative yx in my image. The x and the y exchange places. That's how it works. 90 degrees counterclockwise, we've got xy becomes y comma negative x. And 180 degrees, we have xy becomes negative x, negative y. And with apologies, as I was reading this out, I realized that I'd made a mistake here. 90 degrees clockwise, I think I made it in my last table too. 90 degrees clockwise is actually going to be positive. I'll write it out again. Positive y, negative x. And 90 degrees counterclockwise should read negative y, positive x. So I'd like to clarify that. 90 degrees clockwise, your old point is xy. Your new point is y comma negative x. 90 degrees counterclockwise, we're at the point xy. Originally, our new point is going to be negative y and x. And 180 degrees, I didn't mess that one up. It's xy becomes negative x and negative y.